This is something that I certainly didn't understand in high school, and so hopefully I can explain it to you so you don't have the same fate. A Lewis acid is any chemical that can accept an electron pair. If an electron pair or a lone pair on a chemical can attach itself to a molecule or ion, that makes it a Lewis acid. The Lewis base is the thing that has the lone pair of electrons on it. In fact, if it has a lone pair of electrons, it can act as a Lewis base, but only to certain things. Take a look at this reaction. I've got SO3 reacting with water, H2O, to form sulfuric acid, H2SO4. This is actually the reaction that leads to the formation of acid rain when there are too many sulfur oxides in the atmosphere. But that's not what's important. What's important is, how the heck is this reaction happening? Well, let's take a look. I've got 3 oxygens attached to my sulfur here, but I got 4 attached here. That means this oxygen has somehow latched itself on to the sulfur. How could that have happened? This lone pair on the oxygen attacks the sulfur, and that lone pair is now found in one of the bonds here. This electron pair was donated by the water. It was accepted by the SO3. See how it's accepting the gift of a lone pair? This is accepting an electron pair, which makes this a Lewis acid. This is giving away its electron pair for the greater good of the formation of this molecule, which makes this the Lewis base. It's confusing to call them acids and bases because there's no real proton exchange here, but you got to accept it. The thing that donates the electrons is the base, the thing that takes them is the acid. Let's try this again. What's going on here? Proton plus water makes the hydronium ion. Well, clearly, this oxygen has 3 hydrogens and it only had 2 here. So these electrons must have latched on to the H. This H accepted those protons. Accepted the electrons, my mistake. Accepted the electron pair. Well, that makes this a Lewis acid. This gave away its proton pair. How generous of it. That makes it a Lewis base. Let's try this again. This carbon has an H and 2 O's on it. Here it has an H and 2 O's, but it also has an F attached. How'd that F get there? Well, the F has a lone pair of electrons on it, and it may have attacked the carbon. In the process, this electron pair got booted out, but you may not be familiar with how the dynamics of electrons work in reactions yet. The point is that this C accepted the gift of an electron pair from the fluorine. What a gracious receiver. That makes it a Lewis acid. And the F gave its electron pair for the good of the bond. That makes it the Lewis base. If you can figure out which chemical donates the electron pair and which one accepts the electron pair, you can tell the difference between a Lewis acid and a Lewis base. And don't forget, they're electron pairs, not proton pairs. Best of luck.